Here's a question that sounds simple, but it's not. What's actually holding you together right now? Like, seriously, what is keeping every atom in your body from just exploding into pure energy? Because here's something they don't tell you in school. You're not made of matter. Not really. You're made of trapped light, frozen energy, bottled lightning pretending to be solid. And the amount of energy locked inside your body, just sitting there, doing nothing, is enough to power every city in America for a month. Yeah, you heard that right. You, right now, sitting there. You're basically a walking nuclear bomb that just happens to not be going off. And Oppenheimer understood this in a way that almost nobody else did, in a way that haunted him until the day he died. If this kind of stuff makes you wonder what else you don't know about reality, hit subscribe, because what I'm about to show you is going to change how you see literally everything around you. The walls, your phone, your own hands, all of it. Nothing is what you think it is. And Oppenheimer figured out exactly why. So, let's start with something you probably never thought about. Take your hand and look at it. Really look at it. Feels solid, right? Feels real. Feels like matter. But here's what Oppenheimer knew that most people still don't know today. That hand you're looking at, the one that feels so solid and real and physical, is 99.9999% empty space. And the tiny fraction that isn't empty space, the little bits that seem like actual stuff, those aren't really particles at all. They're vibrations in quantum fields, mathematical disturbances in space-time that only appear to exist when you measure them. You're an illusion held together by forces so powerful they can level cities, or so weak they can barely exist. And the difference between those two states, between you sitting there watching this and you becoming a flash of light that vaporizes everything within 10 miles, that difference is smaller than you can possibly imagine. That's what got to Oppenheimer. Not the physics itself, but what the physics meant. Think about this for a second. Every single thing you've ever touched, every wall you've leaned against, every chair you've sat in, every person you've hugged, you never actually made contact with any of it. Not once. Not ever. What you felt was electromagnetic repulsion, the electrons in your atoms pushing against the electrons in their atoms. It's force, not touch. Energy, not matter. And that force, that invisible wall between you and everything else, is the only thing preventing the energy locked inside matter from being released. Change that force, break that barrier, and the hidden power comes flooding out. And Oppenheimer spent years figuring out exactly how to break it. Now here's what they teach you in high school, and it's not wrong exactly. It's just incomplete in a way that completely misses the point. They tell you atoms are made of protons and neutrons in the nucleus, with electrons buzzing around them. Positive charges, negative charges, neutral particles, everything balanced out, and that picture works fine for chemistry, for understanding why salt dissolves in water, or why iron rusts. But it doesn't tell you the really disturbing part. It doesn't tell you about the energy. See, when you put protons and neutrons together to make a nucleus, something weird happens. The mass of the nucleus is less than the mass of the individual particles that went into it. Not a little less, a lot less, like measurably, significantly less. Where'd that mass go? It didn't just disappear. It turned into binding energy, the force that holds the nucleus together. And here's where Einstein comes in with the most famous equation that nobody really understands. E equals mc squared. Energy equals mass times the speed of light squared. And the speed of light is a big number, 186,000 miles per second. When you square that, you get an absolutely insane number. 34,600,000,000 miles squared per second squared. So even a tiny amount of mass, when you multiply it by that number, becomes a mind-blowing amount of energy. A single gram of matter, if you could convert it entirely to energy, would release 21.5 kilotons of explosive force. That's bigger than the bomb that destroyed Nagasaki. 1 gram. The weight of a paperclip. And you're made of about 70 kilograms of matter. Do the math, and it gets uncomfortable fast. But here's where the paradox comes in, where the whole thing stops making sense if you really think about it. If every atom is carrying this massive amount of energy, why isn't everything just constantly exploding? Why can you hold a rock without it vaporizing your hand? Why doesn't the table you're sitting at spontaneously turn into a fireball? The answer is forces. Specifically, the strong nuclear force, one of the 4 fundamental forces in the universe. This force holds the nucleus together, and it's strong. Like, ridiculously strong. About 100 times stronger than the electromagnetic force that holds atoms together. It has to be that strong because the nucleus is a terrible place to be. You've got all these protons crammed into a space about 10 to the negative 15th meters across. That's 0.000000000000001 meters. Insanely tiny. And all those protons have positive charge, which means they're pushing against each other with enormous force. Positive repels positive. At the distances inside a nucleus, the electromagnetic repulsion between protons is massive. So why don't they just fly apart? The strong nuclear force. It's stronger than the repulsion, but only at incredibly short distances. Get protons just a little bit farther apart, and the strong force drops to 0. It's like glue that only works if things are touching. And that's the paradox Oppenheimer grappled with. The nucleus is simultaneously the most stable thing in the universe and the most unstable. It's held together by the strongest force we know. But that force is fighting against massive repulsion. It's a balance, a tension. And if you disturb that balance just right, if you add energy in exactly the right way, the whole thing comes apart. And when it does, the binding energy gets released. The energy that was holding the nucleus together becomes kinetic energy, heat, light, radiation. An explosion. Except here's the problem. That energy is locked up tight, trapped. The forces holding atoms together are so strong that under normal circumstances, nothing can break them. You can burn wood and release chemical energy from the bonds between atoms. You can compress a spring and release mechanical energy. But the energy inside the nucleus, the binding energy that Oppenheimer spent years studying, that's a different beast entirely. Chemical reactions rearrange electrons. Nuclear reactions break apart the nucleus itself. And the energy difference between those two types of reactions is about 1,000,000 to 1. 1 kilogram of uranium undergoing fission releases about 3 million times more energy than 1 kilogram of TNT exploding. Same mass. 3 million times more energy. Because nuclear binding energy is just that much more intense than chemical binding energy. And that's what Oppenheimer understood. That there was this hidden layer of reality, this secret reservoir of power inside every atom that humans had never accessed before. Until he figured out how. Picture this, and really try to visualize it, because this is where it gets wild. You're standing in a room, and someone hands you a marble. A single glass marble. Feels like nothing, right? Weighs maybe 5 grams. You toss it up and down in your hand. Completely harmless. You could throw it, and maybe break a window. That's about it. Now imagine that marble is made of uranium-235. Still looks the same, still weighs about the same. But something is different now. Deep inside that marble, in the nucleus of every uranium atom, There's an instability. The nucleus is too big. Too many protons crammed together, all pushing against each other because positive charges repel. It wants to split, but it can't. Not on its own. It needs a trigger. So someone hands you a neutron. Not a physical object you can see, but imagine it anyway. A tiny particle with no charge that can slip right past the electrons like a ghost walking through walls and smack directly into the nucleus. You throw the neutron at the uranium marble. It hits, and in that instant, in a time span so short, it makes a nanosecond look like an eternity. In about 1/1,000,000th of a second, the nucleus absorbs the neutron, becomes unstable, wobbles like a water droplet, and splits apart. Fission. The nucleus breaks into two smaller pieces, usually barium and krypton. And here's the thing Oppenheimer understood better than almost anyone at the time. When that nucleus splits, the two pieces together weigh less than the original uranium atom. Not much less. About 0.1% less. But remember, E equals mc squared. That missing mass didn't disappear. It turned into energy. A tiny flash of heat and light and gamma radiation. From one atom. One single atom splitting releases about 200 million electron volts of energy. Now, 200 million electron volts sounds like a lot, but it's actually tiny in human terms. It's about 3.2 times 10 to the negative 11th joules. That's 0.000000000032 joules. Basically, nothing. You wouldn't even feel it. But here's where it gets insane. That one atom that just split also released 2 or 3 extra neutrons. And those neutrons are moving fast, really fast, and they're gonna hit other uranium atoms. And those atoms are gonna split. And each of those splits releases more neutrons. And suddenly, you've got a chain reaction. 2 becomes 4, becomes 8, becomes 16, becomes 32. Exponential growth. Within a millionth of a second, you've got trillions of atoms splitting. And each one is releasing that 200 million electron volts. Add it all up, and now you're not talking about 0.00000000032 joules. You're talking about kilotons, megatons, city-destroying amounts of energy. All from that one marble. All from splitting atoms. And Oppenheimer was the guy who figured out exactly how to make that chain reaction happen fast enough, concentrated enough, controlled enough to turn a ball of metal the size of a grapefruit into a fireball hotter than the surface of the sun. Let me give you another way to think about it, because this is hard to grasp. Imagine you've got a room full of mousetraps, thousands of them. Each one is set and ready to snap. And on each mousetrap, you've balanced 2 ping-pong balls. Now you throw one ping-pong ball into the room. It lands on a mousetrap. Snap. That mousetrap springs and launches its 2 ping-pong balls into the air. Those 2 balls land on 2 more mousetraps. Snap, snap. Those launch 4 balls. Those 4 hit 4 traps and launch 8 balls. Within seconds, the entire room is chaos. Mousetraps snapping everywhere. Ping-pong balls flying in every direction. That's a chain reaction. Now replace the mousetraps with uranium atoms. Replace the ping-pong balls with neutrons. And replace the snapping sound with nuclear fission, releasing millions of electron volts of energy. That's what happens in a nuclear weapon. And Oppenheimer understood the math. He knew exactly how many uranium atoms you needed. He knew how pure the uranium had to be. He knew how fast the chain reaction would propagate. He knew what the critical mass was, the minimum amount of fissile material needed to sustain a chain reaction. For uranium-235, it's about 52 kilograms if you just have a sphere sitting there. But if you compress it, if you squeeze it with conventional explosives to increase the density, you can go critical with less material. That's what the implosion design does. That's what the Nagasaki bomb used. And Oppenheimer figured all this out with just math and experiments and theoretical physics. No computer simulations, no test data, just physics and intuition and raw intellectual power. And this is where Oppenheimer realized something that haunts physics to this day. The energy inside matter isn't just theoretical. It's not just numbers on a page. It's real, measurable, accessible energy that changes everything about how we understand the universe. When he was working at Los Alamos from 1942 to 1945, Oppenheimer wasn't just building a weapon. He was proving that Einstein was right. That E equals mc squared wasn't just an elegant equation scribbled on a chalkboard, it was a description of reality. And the implications were terrifying. See, before the Trinity test, before anyone had ever seen a nuclear explosion, there was this tiny possibility that the physicists were wrong about everything. Maybe matter couldn't be converted to energy. Maybe the calculations were off. Maybe the whole thing would fizzle. There were even bets among the scientists about what would happen. Some thought it wouldn't work at all. Some thought it would work, but be small. And some, including Oppenheimer, worried it might work too well. There was even a brief panic where someone calculated that the nuclear explosion might ignite the nitrogen in the atmosphere and set the entire sky on fire, burning the whole planet. They did more calculations and decided the probability was 0, but the fact that they even had to check tells you how far into the unknown they were going. But at 5:29 in the morning on July 16, 1945, when the device they called the gadget detonated with a force equivalent to 22 kilotons of TNT, when the flash was visible from 180 miles away, when the mushroom cloud rose to over 7.5 miles high, when the heat was so intense it turned the desert sand into green radioactive glass, they later called Trinitite, all doubt vanished. The energy was real. And Oppenheimer watched it happen and later said, "Now I am become death, the destroyer of worlds." He was quoting the Bhagavad Gita, an ancient Hindu text he'd studied for years, a sacred scripture from a religion that wasn't even his own, but that he'd learned Sanskrit to read in the original language. But he wasn't being poetic. He wasn't being dramatic. He was being literal. He'd just proven that humans could access the hidden power of matter. And that power was exactly as devastating as the math predicted. Before I get to what this really means, drop a comment telling me where you're watching from, because I'm genuinely curious how far around the world people are who want to understand this stuff. Now, here's what almost nobody talks about when they talk about the atomic bomb. The actual efficiency of the first weapons was terrible. The Hiroshima bomb, little boy, used about 64 kilograms of uranium-235. But only about 700 grams of that actually underwent fission, less than 2%. The rest of the uranium just got blown apart by the explosion before it could react. The chain reaction was so violent that it blew itself apart in microseconds. And that 700 grams, when converted to energy according to E equals mc squared, released about 15 kilotons of explosive force, enough to kill over 140,000 people. Enough to level everything within a mile of ground zero. Enough to start fires 10 miles away. From 700 grams. Now imagine if they'd achieved 100% efficiency. If all 64 kilograms had fissioned. The numbers become incomprehensible. But even at terrible efficiency, even with 98% of the fuel wasted, the hidden power in matter was enough to erase a city from existence in seconds. And Oppenheimer knew this before it happened. He'd done the calculations. He'd run the numbers over and over. He knew exactly how much energy would be released. What he didn't know, what he couldn't know until he saw it with his own eyes, was what it would feel like to watch the math become real. And here's the thing that disturbed him most, according to people who were there with him that morning in the New Mexico desert. It worked exactly as predicted. The fireball temperature was around 60 million degrees Fahrenheit in the first microsecond. The blast wave traveled outward at the speed of sound initially, then slowed as it expanded. The radiation levels matched the calculations. The yield was within the expected range. Nature didn't deviate from the equations even slightly, which meant the equations were right, which meant the hidden energy in matter was exactly what they'd calculated it to be. And if it was real in uranium, it was real in all matter, including plutonium, including hydrogen, including the matter in human bodies. Oppenheimer once said, "The physicists have known sin, and this is a knowledge which they cannot lose." What did he mean by that? He meant that once you've proven you can turn matter into energy on command, once you've shown that the hidden power is accessible, that it's not just theoretical but practical and weaponizable, you can't unprove it. You can't unknow it. The secret is out. The genie is out of the bottle. And it changes what it means to be human. Because now we're not just a species that uses energy like fire or steam or electricity. We're a species that can deliberately convert matter to energy. We're not burning fuel. We're destroying mass itself and harvesting the energy that pours out. And that's a different category of power entirely. That's the power that runs stars. And Oppenheimer gave it to humanity. And here's what got to Oppenheimer, what haunted him for the rest of his life until he died in 1967. You're not made of solid stuff. You're made of energy temporarily organized into a pattern called you. Every atom in your body is a tiny trapped sun, an absurd amount of energy held in balance by forces we barely understand and can't directly perceive. The nucleus of a single carbon atom in your body, just one atom of the billions of billions that make up your cells, contains binding energy equivalent to about 92 million electron volts. That's the energy it would take to completely tear that nucleus apart into individual protons and neutrons. Doesn't sound like much, right? 92 million electron volts. But you've got about 7 billion atoms in your body. 7 times 10 to the 27th. That's a 7 followed by 27 zeros. The total binding energy locked inside your body, if it could somehow all be released at once, if every nucleus could be broken down into individual particles, would be roughly equivalent to 400 megatons of TNT. That's more than 25,000 Hiroshima bombs worth of energy, sitting inside you, right now. You're not just watching a video about energy, you're made of it. You are it. Every breath you take, every thought you think, every movement you make is happening inside a body that contains enough potential destructive power to devastate a continent. And the only reason you're not exploding, the only reason you're not turning into a flash of gamma radiation that would sterilize everything within 100 miles, is because the conditions required to release that energy are so incredibly specific, so precisely calibrated, that they almost never occur naturally anywhere in the universe except inside stars. But almost never isn't the same as never. And that's what Oppenheimer understood in a way that kept him awake at night. The line between matter staying stable and matter releasing its energy isn't a thick protective wall. It's a razor-thin edge balanced on quantum probabilities. Change the conditions just slightly. Add a neutron here, compress the material there, and everything changes. Stability becomes instability. Matter becomes energy. And we figured out how to change those conditions. We figured out how to push matter over that edge on purpose, with intention, with precision. What does that mean for what we are? For what reality actually is at the deepest level? If you're mostly empty space held together by frozen energy and quantum forces, what exactly are you? Are you matter or are you energy? Are you a thing or are you a process? Oppenheimer looked at the atom and didn't see particles bouncing around like tiny billiard balls. He saw potential. Potential to create, to build, to power civilizations, to light cities, to push humanity forward, to understand the fundamental nature of the universe, but also potential to destroy, to erase, to end things permanently, to kill hundreds of thousands, to poison land for generations, to create weapons so destructive that using them might end civilization itself. And he realized the line between those two things, between creation and destruction, between the power that lights a city and the power that erases it, was way thinner than anyone wanted to admit. It's the same energy, the same physics, the same conversion of mass to energy, just applied differently. When you split an atom, you release energy. When you fuse atoms together, you also release energy. The sun does fusion every second of every day, combining 4 hydrogen nuclei into 1 helium nucleus and releasing the energy that makes life on Earth possible. Every photon of sunlight that touches your skin, every ray of light that lets you see, every bit of warmth you feel on a sunny day, traveled 93 million miles from a fusion reaction happening in the sun's core. That energy came from matter, converting to energy through E equals mc squared. The exact same equation that powers the bombs. Same physics, different application, different intent. And that's what Oppenheimer grappled with for 22 years after Trinity, from 1945 until his death in '67. The knowledge that the universe runs on this hidden power, that stars shine because matter is secretly energy in disguise, that everything solid is secretly fluid at small enough scales, that the boundaries between things are arbitrary human constructs, and the real truth is energy taking temporary forms and calling itself matter. He saw through the illusion of solidity. He saw that matter is just a convenient lie we tell ourselves so we can navigate reality without going completely insane from the strangeness of it all. So next time you touch a table, hold a glass of water, hug someone you love, shake someone's hand, pick up your phone, lean against a wall, remember this: you never actually touched anything. Not once in your entire life have you made physical contact with another object. What you feel, what your brain interprets as touch, is electromagnetic force. It's the electrons in your hand repelling the electrons in the object. Force, not contact. Energy, not matter. You are a cloud of quantum probability, functions interacting with other clouds of quantum probability functions. And the interaction, the repulsion, the force field between you and everything else, that's the only thing preventing the energy locked inside matter from being released. It's the barrier, the dam, the seal on the bottle. And inside that bottle is enough energy to power civilizations or erase them from the map depending on how you open it. Oppenheimer saw that. He proved it. He showed the world that it was real, and he could never unsee it. After Trinity, after watching the first atomic explosion light up the desert dawn, after Hiroshima on August 6, 1945, killed between 90,000 and 146,000 people, after Nagasaki on August 9th killed between 60,000 and 80,000 more, after seeing the photographs of the devastation and the burns and the shadows permanently seared into concrete where people had been standing when the flash hit them, Oppenheimer changed. People who knew him before and after said he looked older, haunted, like he'd aged 10 years in 10 weeks. His eyes looked different. Something in them had shifted. He'd proven that humans could access the hidden power in matter. He'd shown that we could deliberately convert mass to energy with precision and control, and use it as a weapon. And that knowledge came with a burden that never lifted. Because now, it's not theoretical anymore. Now we know for certain that the solid world is an illusion, that matter is frozen energy, that the power to reshape reality on a fundamental level is hiding in plain sight in every atom of every object you've ever touched or will ever touch. And here's the question Oppenheimer never fully answered, the question that still haunts physics and philosophy today. If matter is just energy in temporary form, if the boundaries between objects are just convenient fictions, if the hidden power is real and accessible and weaponizable, what are we? What does it mean to exist as a physical being in a universe where physicality itself is negotiable? Are we matter that somehow learned to think? Or are we energy that learned to organize itself into patterns complex enough to ask questions about what it is? Oppenheimer looked into the atom expecting to find the building blocks of reality and instead found infinity. He found that the smallest things contain the largest energies. He found that creation and destruction are the same force applied with different intentions. He found that reality is stranger, more fluid, more dangerous, and more beautiful than we can possibly imagine from our limited perspective. And he found that once you know this, once you really understand it at a bone-deep level, you carry a weight that never goes away. The weight of knowing what's possible, what's hidden, what's waiting inside every piece of matter in the universe. The weight of knowing that you gave humanity the keys to ultimate power, and there's no taking it back. Can you look at the world the same way after knowing this? Can you touch something, anything, without thinking about the frozen energy inside it waiting to be released? Can you look at your own hand without wondering what it would take to unlock the power hiding there in every atom? Oppenheimer couldn't. He tried. He went back to teaching. He directed the Institute for Advanced Study. He gave lectures. He advised presidents. But the knowledge never left him. And maybe that's the price of really understanding reality at its deepest level. Maybe that's the price of seeing past the comfortable illusions we build to make existence bearable. If this video changed how you see the physical world around you, if it made you question what solid actually means, smash that like button so I know this stuff matters to people. Subscribe if you want to keep discovering the secrets that physics doesn't usually tell you, the stuff they leave out of textbooks because it's too disturbing or too strange or too hard to accept. And drop a comment telling me which Oppenheimer discovery you want me to explore next, because trust me, there's so much more to this story than what I covered here. Thanks for watching.